In this video, we're gonna continue on 1.2, and we're gonna introduce stem, leaf plots, dot plot, and the shape of a distribution. First of all, let's take a look at the stem leaf plot. A stem leaf plot uses digits to the left of the rightmost digit to form the stem. Each rightmost digit forms a leaf. Now let's take a look at example here. We got number 147. So based on the definition here, each rightmost digit forms a leaf, which means 7 is gonna be the leaf, and the digits to the left of the rightmost digits would be the stem. So in this case, 14 would be the stem. Now, once we know the definition or how to determine the leaf and the stem, let's take a look at how to draw a stem and leaf plot by going over this example over here. So the example says an individual is considered to be unemployed if they do not have a job but are actively seeking employment. The following data represent the unemployment rate in each of the 50 United States plus the District of Columbia in June 2008. And we got a bunch of different numbers over here, and based on the definition of stem leaf plot, if we want to draw a stem leaf plot, we need to determine the stems and leaves. So of course, we know that since each observation in this table has 2 digits, so which means the right digit would be the leaf and the left digits would be the stems. So first of all, let's take a look at how many different stems we have, which means we want to see how many different numbers on the left digit. So for the left digit, we got a 4, 6, and then 5, and then 3, and then 8, and then 7, and then 2. So in other words, we get different stems for 2, 3, 4, 5, 6, 7, and 8. So if we want to draw a stem and leaf plot, first of all, we gotta write down stem and leaf over here, and draw a vertical line between them. And then we write down all of the stems in ascending order. So as what I just mentioned, we have 2, 3, 4, 5, 6, 7, and 8. And then we just go ahead to find the leaves corresponding to each stem. Now, first of all, let's take a look at the leaves corresponding to 2. So based on what we just we got over here, we only have one number with stem 2, which is 2.8. And then we just write down the leaf over here, which is 8. And that's it. That's for number 2, stem 2. Let's take a look at stem 3. So let me clear this a little bit. So with the left digit 3, we have left digit 3. We have 3. We got 8, and then 8 again, and then 8 again, and then 3, and then 9, and then 2, and then 9 again, and then 2 again, and then 2 again. That's for stem 3. Now let's take a look at stem 4. We have leaf 7, and then 8, and then 2, and then 0, and then 3, and then 0, and then 1, and then 0, and then 4, then 7, 0, 6, then 6, That's for stem 4. Now let's take a look at stem 5. We have a 0 here first of all, and then 1, and then 4, and then 5. 5 over here, 7, and then 8, and then 3, and then 2. Let me rewrite this. Clear, and then 5.2, and then 3, and then 7, and then 3 again, and then 3 again. And then got a 5 here, and then 2 here, and then 5 here, and then 3 here. That's for stem 5. Now let's take a look at stem 6. So we got 6, got 8, 9, 4, 8, then 3, 9, 4, 0, and then the third column, first one is 6, and then 2, and then 5, and then that's it. And then let's take a look at stem 7. And for the stem 7, we only have 1, which is 7.5, so we put 5 over here. And then for stem 8, we have only 1, which is 8.5. So we got a 5 over here. And that's pretty much the first 2 steps. And what we got here is pretty much exact same thing as showed up over here. Okay, but we're not done yet. So once we got here, a finish, as what I mentioned over here, a finished stem leaf plot has the leaves in ascending order. So basically, we need to reorder the leaves over here. Let's reorder it over here, stem and leaf. Stem 2. So since we only have 1 number, so that would be 8 here. And then stem 3, we gotta reorder this. The smallest number is 2, and we got 3 of them, so 2, 2, 2. And then 3, and then we got a 3, 8, 8, 8, 8, and 2 9s, 9, 9. For stem 4, we have 1, 2, 3, we get 3 zeros, 1, 2, 3, and then we have a 1, and then we have a 2, and then we have a 3, and then we have a 4, and we have a 6 here, and we have 7, 2 7s, 7, 7, and then we have 8. For stem 5, 0, and then 1, and then we got 1, 2. We got 2 2s, 2, 2. And then 1, 2, 3, 4, 5. We got 5 3s. 1, 2, 3, 4, 5. And we got a 4. We got a 5, 5, 5. We got 3 5s. And then we have a 7. And then we have 8. Number 6. So smallest number is 0. And then we have a 2. And then we have a 3, and then we have a 2 4s, 4, 4. And then we have a 5 here, and then we have a 6, and then we have 2 8s, 8, 8, and then 2 9s, 9, 9. And then stem 7, we only have a 5, write it down. Stem 8, only have a 5, write it down. Now we're almost done. So there is only one more equally important part, which is the key of this plot. So without the given raw data here, if I just have the stem and leaf plot over here, How do I know? How do I know what does 2a represents? Does it represent 2.8 or 28 or 0.28? What is it? I don't know. So we need to put a key here. And some places called legend as well. Put a key here, which is 2 vertical line 8 is equal to 2.8. This part is super important. You cannot miss it. If you do miss it, I don't know what does the whole or plus represent, okay? Now, once we got this done, let's take a look at the steps in general of constructing the stem and leaf plot. Step 1, the stem of a data value will consist of the digits to the left of the rightmost digits, and the leaf of data value will be the rightmost digit. So basically, we gotta know how to determine the leaves and the stems. Step 2, write the stems in a vertical column in a increasing order. Draw a vertical line to the right of the stems. Step 3, write each leaf corresponding to the stems to the right of the vertical line. That's what we did. Step 4, within each stem, rearrange the leaves in ascending order. Title the plot and include the legend. Of course, it could be a legend or it's also called the key to indicate what the values represent. So that's pretty much what we got here. So write down the stem, leaf, and write all the stems in increasing order, and find out the leaves corresponding to each stem, and then rearrange the leaves in ascending order. And at the end, don't forget, write down the legend or the key here to tell people what does the values in the plot represent. Okay, and there's a little tip for the stem leaf plot. When data appear rather bunched, we can use split stems. So since what we got here, this kind of the leaves are here is kind of long. So to make it look more clear, we used to split the stems, just like this stems over here represents 3.0 through 3.4, and the second one represents 3.5 through 3.9. Why do we just split it like this? Because for the values of the leaves, there are only 10 possible numbers. They are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? And then we want to split it from the middle, which is here. So the first 5 numbers are 0 to 4, and second 5 numbers are 5 to 9. And that's pretty much how we split the stems. So since we only have one leaf for the stem 7 and stem 8, so you can put this over here, and with the right hand side empty, or like this, or you can just get rid of it. It's up to you. So both way gonna get the full credits. And that's pretty much all about how to draw a stem and leaf plot. So once we know how to draw stem leaf plot, let's take a look at why. Why do we use stem leaf plot? What's the advantage of the stem leaf plot? So once a frequency distribution or histogram, or histogram of continuous data is created, the raw data is lost. Usually it's reported with a frequency distribution. However, the raw data can be retrieved from the stem and leaf plot. Why? Because as what we learned in the previous video, we know that a histogram or frequency distribution of a continuous data. For this kind of table and graphs, we only know the frequency of each class. Once the raw data was lost, there's no way we can know that the exact value of every observation from the frequency distribution or from the histograms, because we only have the frequency of each class. We don't have the frequency of each exact observation. But the raw data could be retrieved from the stem leaf plot. So based on the data, based on the stem leaf plot we have over here, we can find out. Of course, we need to write down the key. 2 vertical line 8 is equal to 2.8. Okay. So once we have the key and we have the stem leaf plot, we can retrieve every single observations from the raw data. For example, we know this is 2.8, and then 3.8, 3.8 from here, and so forth. That's the big advantage of the stem leaf plot. And I wish this makes sense to you. So once we know how to draw and how to draw stem leaf plot and its advantage, let's take a look at the next plot, which is called the dot plot. Dot plot is quite easier to understand. A dot plot is drawn by placing each observation horizontally in increasing order and placing the dot above the observation each time it is observed. So basically, based on the definition, if you want to draw a dot plot, first of all, you gotta figure out all of the different observations and put them in a increasing order on the horizontal axis. Just like what we did, it was showed over here. Okay, so based on the example over here, the following data represent the number of available cars in the household based on a random sample of 50 household. Draw a dot plot of the data. So of course, we have 0, 1, 2, 3, 4, and 5. With all 6 of them different numbers. So we put them in ascending order on the horizontal axis. And the definition says that we want to place a dot above observation each time it is observed. For example, the first number is 3. Once we have a 3, we put a dot above 3. Second number is 0. I put a dot above 0. Third number is 1. I put a dot above 1, and so forth. So without the raw data here, if we just look at the dot plot down here, we can retrieve the raw data as well, because from here we get a 4 dots above 0, which means we get 4 zeros in the raw data. So let's take a look at if it's true or not. So let me clear this a little bit. So for zeros, we have 1, 2, 3, and 4. We got 4 zeros, which is same as what we got from here. And we only have 1 5. Yes, we only have 1 5 here. And for the 4, we have 3 dots above 4, which means we have 3 4s in the raw data. 1, 2, and 3. And so forth is same as 1, 2, and 3. And that's pretty much how we draw a dot plot. And I think that's quite straightforward. So basically, if you want to draw a dot plot, just put all the different observations on the horizontal axis, and once the observation is observed one time, you put a dot above the observation, on the horizontal axis. All right, that's pretty much all about the dot plot. So the very last part of this video is identifying the shape of a distribution. So we're gonna talking about the 4 different shapes of distribution. The very first one is called the uniform distribution. This is very important, and we're gonna see this kind of distribution a lot in the future. Okay, the uniform. Let's take a look at the graph first. The uniform distribution. The frequency of each value of the variable is evenly spread out across the value of the variable. Since the frequency of each value is evenly spread out across the values of variable, that means each observation has the same frequency. in the term of histogram, that means each rectangle has the exactly same height. Now let's take a look at the graph of the uniform distribution. So this is a uniform distribution, and it's also called a, of course, it's a symmetric. This is not called symmetric distribution, okay? This is called a symmetric distribution, but this graph is symmetric. So based on the definition, we can tell since each rectangle in the histogram has the exactly same height, which means the possible values is evenly spread out. So this is a uniform distribution. And in the future, if you say something like this, every rectangle has the same height, is always a uniform distribution. Okay. Second one, the bell-shaped distribution, and is also called a symmetric unimodel. The highest frequency occurs in the middle, and the frequencies tail off to the left and the right of the middle. Now let's take a look at the graph here. Now we can tell the highest occurrence occurs in the middle, and it tails off to the left and to the right of the middle. And a bimodal histogram has two different peaks, and a histogram with more than two peaks is said to be multimodal. So that means it could be something like that. Something like this. Of course, that's gonna be the bimodal, and then something like this. And this is called the multimodal. Right. The third one is called skewed right, and it's also called positively skewed. And in this case, the tail to the right of the peak is longer than the tail to the left of the peak. Now we can tell from the graph, the tail to the right of the peak is longer than the tail to the left of the peak. So this case would be skewed right. And for the skewed left, and it's also called negatively skewed, the tail to the left of the peak is longer than the tail to the right of the peak. And the tail to the left of the peak is longer than the tail to the right of the peak. And this case is skewed left. And that's pretty much all I want to talk about in this video.